Have you ever just looked at something like a snowflake or even the human brain and just thought, how? How does something so incredibly complex come from a set of really simple basic rules? Well, today we're going to dig into a really cool conceptual model that gives us a new way to think about that exact question. It's all inspired by this idea of harmonizing patterns. Okay, let's get into it.
You know, this is one of those big questions that you hear in science all the time, right? From the way molecules dance around in biology to the giant cosmic scale of the universe. How do we get from these simple, almost boring building blocks to the absolutely mind-blowing complexity that we see everywhere?
So we're going to do something a little different today. Before we even get into the nuts and bolts of this model, we're actually going to talk about what it isn't. Yeah, we're going to build a fence around the idea first. It's super important to understand the boundaries here, because only then can you really appreciate what it's trying to do.
All right, so this first part is all about setting the stage. I want you to think of what we're about to explore as a specific lens for looking at the world. It's not a law of nature, not at all. It's just a new and I think powerful perspective.
Okay, first and foremost, and this is probably the most important thing to get, the framework we're talking about today is not trying to pick a fight with established science. It's not here to challenge anything. It's more like a companion idea.
Right. So in other words, this isn't some new alternative to things like evolutionary biology or biochemistry. Nope. The whole point is that it's designed to sit right alongside them, offering a different kind of insight, one that's more about structure and pattern.
And here's the other critical boundary we need to draw. This model is strictly about mathematical and structural ideas. It has absolutely nothing to say about the bigger, deeper questions of philosophy, religion, where everything came from or why we're here. That's just not its lane.
So, let's just recap the ground rules real quick. We're looking at a conceptual framework. That's it. It's not trying to explain the origin of life. It's a supplementary viewpoint that can happily coexist with other ways of thinking. Okay? Now that we've got that solid foundation, we can actually start exploring the idea itself.
All right, with all those disclaimers out of the way, let's finally get to the core of this thing. The best way to understand it is to think of it as two separate but totally interactive ideas, kind of like the two blades of a pair of scissors.
So on one side, you have what are called assembly heuristics. Just think of these as the simple, creative rules that are constantly coming up with an infinite number of patterns. And then on the other side, you've got the boundary conditions. These are the tough, unforgiving laws of physics and chemistry that decide which of those patterns actually get to exist in the real world.
Let's look a little closer at that first blade, the assembly heuristics. The key word here is simple. Imagine watching a huge flock of birds. Each individual bird is just following a few simple rules, right? Like, stay close to the bird next to you, but not too close. And from those super simple local rules, you get this beautiful, complex, coordinated pattern across the whole sky. That's the basic idea here.
And to help us get our heads around this, the source material brings up things like the Fibonacci sequence. It's a perfect example of a simple rule that creates a beautiful repeating pattern. But, and this is really important, it's just an analogy. It's a way to help us visualize the idea of generative rules. Nobody is saying that this is literally how biology works.
Okay, so now for the other blade of the scissors, the boundary conditions. You can think of this as the ultimate reality check. It doesn't matter how cool or elegant a pattern the heuristics come up with. If it's not physically stable, it's a no-go. Things like thermodynamics and the geometry of molecules, these are the bouncers at the club of reality, and they cut away any structure that just can't work in the real world.
So, we've got one blade coming up with all these possibilities and the other one limiting them. Now let's see what happens when these two forces actually meet. This is where the magic happens. And this brings us to this brilliant idea from the Nobel Prize winner Herbert Simon. He basically argued that a lot of what we see as complex behavior isn't really that complex at its core. Instead, it's just what happens when simple internal rules have to operate inside a complex external environment. And he captured this perfectly with his scissors metaphor.
So let's see Simon's scissors in action. Step 1. The assembly heuristics. That first blade, they just go wild, generating a whole universe of potential patterns. Step 2. The boundary conditions. The second blade swings into action and just ruthlessly snips away everything that's physically or chemically impossible. And what's left? What emerges from this incredible dance between creation and constraint? Well, that's where you find the stable, real-world structures that make up our world.
Okay, so we have this really elegant model of generation and constraint. It's a cool idea. But so what? Why does it even matter? What's the real value of looking at the world through this particular lens?
You know, I think the real value of this model is its intellectual humility. It's offering a purely mathematical and structural way to think about complexity. It's a tool for your brain, designed to complement other ways of knowing, whether that's established science or even personal beliefs, without ever trying to replace them.
Ultimately, this whole explainer has been about the power of one simple idea, that sometimes just finding a new way to describe a problem can be as useful as finding a new solution. This model, it's just one lens, and it leaves us with this really profound question. What other conceptual tools are out there, just waiting for us to find them, that could totally change not what we see, but how we see the world? Thanks for joining me.